Hi there, this video is your section 3 video, which is entitled Linear Inequalities, and at this point we all would have experienced linear inequalities because once you're entering the SAT class, this would have been one of the prerequisite courses complete either for the Caribbean students in your CXC curriculum or for the students worldwide in somewhere in your high school curriculum. We're dealing with a linear inequality represents a range of values or all possible values or an entire set of solutions of x or whichever variable we're dealing with. So what is a linear inequality? It represents a range of values, right? Or all possible values. So it really represents possibilities of an entire solution set. And here's where I want to remind us about our signs in linear equality. So this sign represents greater than, right? We always read our signs from left to right once they stand alone. Greater than, this is greater than or equal to. This is less than or equal to. On the SAT, linear inequalities can be represented in one-dimensional or two-dimensional modes, or I should say models. What we're going to look at now is our one-dimensional graphical representation using a number line and only one variable. So as I said here, these are some prerequisites for using the one-dimensional graphical representation. One, you must have a number line, as you see in the examples here, and two, it must be one variable, and these are some things that you require. Use an open dot, which is this, for greater than or less than inequalities. And then you're going to use a closed dot for greater than or equal to or less than or equal to. So whenever you have equal to involved, you would shade it in. It will be a closed, or we call it a solid dot. And then you use arrows for direction. So you use this arrow, which is pointed towards the right, for greater. So it goes towards the right side, right? Whenever you have greater, what you call it, greater than signs. And then I want to pull this off here. So it goes towards the positive direction, and then use this arrow, which for lesser, and it points to the negative direction or the left side. Let me just blow this back up. Good. So this is an example here where we have an open dot pointing to your right. This example is a closed dot pointing to your right, and this you have a closed and an open. And at this time, I would like to go to the board so that I can kind of walk you through the whole scenario here. So here, all right, excellent. So what we're going to do is, instead of me walking you through what's the examples here, I prefer to kind of walk you through it via like an active mode. So you can still, take a pic or whatever of these examples, but I'm going to walk you through these examples on the board. So we have a situation where we have x is greater than 3. Let me just make my points a bit smaller. So what I'm going to do is draw a number line here, and I'm going to put 1, 2, 3, 4, 5, just basic, and this is 0, and then of course my negative segment, right? I just won't write that in for now. So remember, you're going to use an open dot, right? This is open dot whenever you're just using the signs greater than or less than, and then you're going to use a closed dot whenever so we call this a closed dot whenever you're using greater than or equal to or less than or equal to sign. And then of course we use arrows to point in whichever direction. So this direction signifies increase or greater than, and of course this direction signifies less than or decrease. Good. So the first step in when you have a one variable inequality and you have to graph it in one-dimensional graphing, the first step, so I'm going to give you all in step 1. I would say your step 1 is to locate the value, right? I'll just put locate value. So your value here is 3. So what you do is locate your value and just draw an empty dot, an open dot, right? Because remember, an open dot will be your most basic dot. If you have to shade it in, you will do that accordingly. So you would locate your, I'm going to change the color. You're going to locate your number 3 and you're going to put your place your open dots, right? So that will more or less be your step 2, right? So step 2, locate value, draw open dots, right? We did that. And then step 3 would be to determine, I would just put dot type, whether it's an open or closed dot. In this case, it's just a greater than sign. Whether it was greater than or less than, it will be an open dot. So you're going to leave it open, and then your final step, step 4, would be to utilize, to draw in your arrow, right? Whichever direction, whether it's this way or that way. So how do we determine that? Okay, so x is greater than 3. So therefore, our arrow will point this way, to your right. And this would signify your x is greater than 3 in one-dimensional graphing. Let's do another example right here. So I'll just, oops, my lines are horrible. Please forgive me, guys. Good. So we have 1, 2, 3, 4, 5, 6. Remember, on your SAT, it's multiple choice, so it's not like you would really be actively drawing these things unless you need to draw it for working purposes, but they would more or less give you these in the questions or in your answer choice, and you would have to determine which one is correct. This one is x is less than negative 3. First step is what? Come on, I need to hear y'all. First step is locate value. So we're going to locate negative 3. So this is negative 1, negative 2, negative 3 right here. Draw and open up. And on the one-dimensional graphing, you could either draw it above the number line or you could actually draw it right on the number line. So it really doesn't matter. Your next step is, of course, we locate the value. We went to step 2. We draw an open dot. We need to determine if it needs to be open or closed. Determine dot type, which is your step 3. This will be open because it's just a less than value, and then the next step is to draw your arrow. Because x is less than, we're going to point to your left, so can either be on the number line or above the number line, right? So hopefully you all get a nice get the hang of it. And then let's say if this was x is less than or equal to negative 3, what will change is just shade that in. Just shade it in. Shade your dots in. So instead of me redrawing an example, I'm just giving it right here to you. And finally, I'm going to give you all 2 more examples. I want to label my number line here. 1, 2, 3. So there's negative 5, negative 4, negative 3, negative 2, negative 1. This example says x is less than 3, but greater than or equal to negative 3. Okay, so this here is a situation where your x values are limited. In these cases, your values are infinite because it can go forever and ever. Here, we have a limited situation. So your first step in questions like these would be to take half of the question, half at a time. So you're going to take this half. Number 1, you read this off. X is less than 3. So you locate 3 and you draw your step 2, which is an open dot. And one of my students in my actual classroom session said, here's what, just locate all the numbers at first. And I have no problem with that. So let's locate negative 3 as well. So we're going to locate negative 3 and draw your open dot. So we using our 2 steps. So let's do it that way perhaps. And then you're going to determine what type of dot. So here we go. You cut this in half. So we say x is less than 3. X is less than 3 means your dot is open and your arrow is going to face that way, less than. Then what you do is wherever your variable is, you read it in that direction. So if your variable is in front of, once your variable is in front of the sign, whether the sign is on the right side or the left side of the variable, you read it like that. Which side is closest to the variable? Isn't it the side that's open? So you read this as x is greater than or equal to negative 3. So because x is greater than or equal to, we need to shade in this dot, and we need to point the arrow this way. Whenever you have a situation where the arrows are meeting, you just erase the arrowheads and just draw a solid line. And that's how you would give this example here. Then what if we had another situation where, I'll draw it over here. Oh my goodness, my lines are so horrible. Please forgive me. Right? 1, 2, 3, 4. -1, -2, -3, -4. Handwriting is poor. This is x is greater than 2 and x is less than -1. Okay, so let's find 2. We put our open dot. We find -1, open dot. Then let's read first half. X is greater than 2. You point your arrow this way, right? And then x is less than -1. You point your arrow this way. Good. So these are 4 possibilities, 1, 2, 3, 4, of your one-dimensional graphing. So at this point, of course, I'd like you all to take notes and obviously do some practice. Great, and now we're going to look at the two-dimensional graphical representation of linear inequalities, and this is using a graph, or I should have said here, well, it's already there, using a coordinate plane and 2 variables. So what do you need for your two-dimensional graphical representation? You need to use a coordinate plane with your x and y axes, very important, and you need to use number 2, which is very, very important. You need to use boundary lines. And these are straight lines or lines that represent, of course, your linear equations. There are 2 types of boundary lines. Use a solid line like this if inequality starts as a y is greater than or equal to, or y is less than or equal to. So in other words, you use a solid line whenever you have equal to involved. So this is similar to your solid or your closed dot in the one-dimensional graphing. And then you use a dashed line if the inequality has greater than or less than. This is also similar to the open dot in your one-dimensional graphing. No equal sign is involved here at all. So you must have some opening of this line here, right? So you use boundary lines for your straight lines or your linear equations, and then half planes. Why do I have all these red underlines? Please ignore that. So half planes are the shaded regions of your two-dimensional graphical representation. If the inequality has any greater than involved in it, then you would shade above the line. And then if the inequality has any less than involved in it, you will shade below the line, right? So I would like, this here is going to show you some examples, and I'm going to use directly each of these examples to show you how we would end up with two-dimensional diagrams. So this is y is greater than 2x plus 3. We're going to look at that now. So y is greater than, I almost put equal to 2x plus 3. And please note, I'm not drawing these to scale. So the first thing, obviously, we need a coordinate plane. Wow, that line is horrible. First thing is I need a ruler. First thing is coordinate plane. We have our x and y axes. Your first step in terms of determining is to be able to identify the correct. So step 1 is to identify correct boundary line. Whew. And remember, we have 2 types of boundary lines. So you have to, how do you identify the correct boundary line? Well, I'll just put part A. You have to get the right type of line, whether it's solid or it's broken. Whew. Please excuse my lines, people. So in this case, we just have greater than. So it means that our boundary line will be the broken line because there's no equal sign involved. The second step in identifying the correct boundary line is identifying the correct linear equation or the correct line. How do you identify a linear equation or a line? You must know the gradients and the y-intercept. Very important. So what I did, I converted this linear inequality here into a linear equation just to be able to get the right line. So 2 is my gradient, so that means really 2 over 1. And 3 is my is my b, which is my y-intercept. So let's say this is 3. And let's say I had, this is my distance 2 as my distance 1 here. So therefore my line, I'm going to use a different color, is going to look something like this. Whoops, sorry for it's not being straight. It's going to be something like this. Obviously, it's not drawn to scale, right? So you all could use a graph paper if you want. So this is the boundary. This is the line. And it's broken because it's just a greater than sign. There's no equal to. And then our next step to drawing this linear inequality, which is the final step, really, step 2, is to locate, wow, handwriting is horrible here. Locate, whoops, locate the half plane, which is your shaded region. Because y is greater than, remember, you all remember where we said the half plane is going to be. Once it's greater than, your half plane goes above the line. So I am just using these yellow streaks here to represent shading above the line. So this, my friends, would represent your linear two-dimensional graphical version of it. So look at it carefully here, and then I want us to look at the example here. So you realize it's more or less the same thing, right? Obviously, mine is not drawn to scale. And then let's look at this example where it says y is greater than or equal to the same 2x plus 3. So in this example, the only thing I'm changing is adding that equal here. And what do? The graph is more or less the same, you know. It's just that the line, instead of being broken, it will be, oh my goodness, this is horrible. Instead of, oh wow, I am not bothering to erase this. You all get the point. It's going to be, oh, this is horrible. I'm sure you're having a laugh. Anyways, the line is going to be solid. And of course, the shading is going to be above because it's still greater than. Yes, let's delete this page and look at other example. The other example says y is less than 2x plus 3. So we're going to look at this example that says y is less than 2x plus 3. Ooh, not c, plus 3. So what we're going to do is draw the plane. Horrible line. And because it is just less than sign, it's just going to be broken line like this. That's your boundary line. And remember, because it's less than, your shaded region is actually going to be below the line, like here. So it's going to be below the line. Got it? And what about if it was y is less than or equal to? Then this red line here will be, instead of broken, it's going to be solid instead. Good? And if you were to look back at the PowerPoint here, you realize in this case it's broken because it's just less than, but it's shaded. The region is below the line because it's less than. In this case, it's less than or equal to, so my boundary line is solid, but of course the shaded region doesn't change. So this is how you can identify your two-dimensional graphical representation. And finally, we're going to look at systems of linear inequalities, finding solutions for linear inequalities. The solution of a system of linear inequalities is a region of points where both inequalities are true and at the same time. And this is basically, in a nutshell, where the shaded regions overlap of the both inequalities. So you all see right here where the shaded regions overlap. So here is obviously blue, here is obviously green, but here looks like a mix. So this right here is where your shaded region overlap. I like to give students a tip, and I tell them find the solution of the two lines first. What is the solution of a linear equation or a line? You all know of or lines is where they intersect at one point. So this is the point of intersection for my two lines. So for me, that's my solution. And once I find the solution, that will more or less direct me to finding the shaded region easily. So I like to say find your point, the point at which your two lines intersect, and then either look above, below, or side to side for that region where you see that overlap. Good. So this is more or less it for linear inequalities. Again, remember your goal is 1 minute per question until you can do 30 to 45 minutes per question. And as I said, always complete suggested questions. These are the questions here. You all can take it down. Page 79, number 7, page 80, number 9 and 10, page 81, number 13, and of course any other questions that I recommend. See ya.